Welcome back, everybody. Welcome back to the channel. So today we're going to be talking about how to process or how to pre-process generic classes. Now, in today's episode, we're going to be talking about generic classes and generic interfaces. Now, I know I've mentioned generic classes previously before, and this is kind of going to be the building blocks for how we process classes in the future in the language. So there's going to be a lot of similarities here, but I just want to get this one out of the way because it's going to set the stage for when we process our first class. Now, one thing I want to mention is that generic classes and generic interfaces are the same thing. So they're treated as pretty much the same way in our programming language. So the way the generic classes are going to work is we're going to have what's called a skeleton. So I'm going to go through the code in a little bit, but we basically just want to like create the class and that's it. We don't want to pre-process anything in there. So like for instance, if I go back out of pre-process generic class and I go into pre-process class declaration, which is going to be the next thing that we're going to be going over, you can see here that after we generate the class that we're trying to create, we're going to basically go through all of the various different things that are inside of that class to pre-process it. So, of course, classes have variables, aliases, and everything else in between that could be inside of a class that we need to pre-process. The reason why you want to do that is because you don't want to process things because it could be contextually based. So meaning that it could be based on a specific type. Now, the reason why I'm telling you this is because it's, like I said, there's a bit of weird things that are happening when it comes to processing generic classes. So if I say class, I don't know, list, or here, actually, let's just go to list class. So here's a perfect example. So in my standard library, I have a list, which is basically just an array list in Java, and it basically holds a set of elements, right? So we have this generic list class of T, and T represents the type. The reason why you don't want to pre-process anything in here is because you don't know like if the variable that's in here is going to be referencing a type that's not processed yet. So we'll see how to do that later on. So if I do a search for compile generic class reference, here's going to be how we do it. So every time we create a generic class, so like let's say, basically the way it's going to work is all of the code that's inside of this generic class is not going to be processed unless we create the generic class. And we're going to have some code that's going to be called a compile generic class reference. And again, the reason why I want to show you this is because you need to think about this stuff beforehand. You can't just do this stuff willy-nilly. So we're going to have this create generic class reference function that we're going to create later. And we're going to basically figure out, okay, where is this generic class located? And of course, we'll go over this code later, like I said, but then we create the name and then we try to find the actual class. So we try to find the represented generic class that was created previously. And if we actually found the actual class, or if we didn't find it, then we'll actually generate it. If we did, we'll just return the value of that. And in here, as you can see, once we get through all this, so we have to do some preliminary setup, which doesn't really matter for right now, but here's the important part. We have a couple different things. So as I mentioned before, there's certain things you can and can't do at certain stages of the compiler because certain information is just not present yet. So what we'll do is we'll effectively just pre-process everything. So all of this code that you're seeing here is going to be all of the pre-processing phase part of the compiler. So as you can see, I set the processing stage to pre-processed. After that, I set it to, so like if we are compiling and we're creating this list class, like let's say inside of a function or something, then we'll basically run all of the code for compiling. Otherwise, we'll put it in what's called a unprocessed class function. And what will happen is we'll basically just inspect the processing stage and provide the appropriate code that needs to be run for based on that stage. So I mentioned all of that to say this is why we don't want to process anything. It's going to kind of be like a magical system, which we'll see later. So let's just see what we do. So we do our basic setup here. Just like everything else, you want to set up your access types. And for class declarations, we have the same stuff here. So I believe we went over this before, right? Yeah, this is the same code that we went over for enums. So it's literally the same code. So we just call parse class access flags, we pass in the flags and the AST. For classes, if we don't have public, private, or protected, it defaults it to public. Otherwise, we add the public flag if we don't have any access types. So all classes are assumed to be public. After that, we have a AST type. So we check to see if this is an interface, basically. So if the AST that we're passed in here is a AST generic interface class declaration, because it's going to be one or the other, and if so, then we check to see if we don't have the stable flag. And what we do is we say stable access specifier is already applied to interfaces. Oh, actually, no. Okay, so I misspoke. So what we do is we call add if. And what add if does is it checks to see if that element is already added to the list. If so, it returns false. Otherwise, it returns true. So if we basically can't add the stable flag, that means that it was already inside of the flags list. So we just want to tell the user that enums or interfaces are stable by default. So this is very important, guys. So when we're creating our classes, we do not want the user to be able to modify interfaces. We want them to be stable extension classes, meaning that it's a stable class, so you can't add extension functions to it because interfaces aren't really classes in the general sense of how we think about them in our programming language. They're just high level constructs for processing information and calling functions. And we also want to make sure we don't have we want to make sure that it's an extension class because we don't want the user to directly be able to instantiate a interface because interfaces are intended to be implemented by a class. And if it's not implemented, when you call the function, you're going to get an exception because there's no subscribers to that function call. We'll go over that later, but yeah, so you want to warn the user about both of these, and you want to pass in the W access warning. That's going to be a warning for access declarations. And again, if the user has that switched off, then they just won't receive that warning. So after that, so after all of that, right, if it's not a generic or if it's not an interface declaration, then we want to add the stable class, or we want to try to find the stable thing here, and if it's not, then we want to add the unstable. So if that's the case, if they don't have it, then you basically just want to set it to unstable, allowing the user to modify the class. After that, you want to get your class name, and then you want to parse an identifier list. Now you want to pass in the current AST, and you want to pass in the identifier list, which is just going to be a string. Now what this is going to be is we're just going to for loop through all of our identifier lists. So if we go to our parser here, we can see that an identifier list is just a identifier, a comma, and then more identifiers. What that is going to be is that's going to represent this part of the actual generic class. So whether it's an interface or a regular class, we're going to have this regardless because it's a generic class. So we're going to need to have at least one identifier, which of course is mandated on the parser side. So here's where we kind of get into some really cool stuff. So really quick, you can kind of see that the parser enforces us to have at least one identifier. So that basically ensures that we have at least one identifier on the compiler side. You want to kind of do that. Now, I know this is kind of late to say this, but when you're building your parser, it is kind of good to try to make catch-all or make protections on the parser side to make it easier on the compiler side so that way you don't have to always check everything and you just know that what you're processing is guaranteed to at least be there. So we're just going to get a key here and we're going to go through each token. If the key is not equal to a comma, then we basically want to add that key to the list. And we don't want the user to have duplicate generic keys. So like if they, for instance, if my list class has T and then comma T, that doesn't make any sense because each identifier needs to be its unique name. So if we can't add it, then we say duplicate generic key, and then we just print that error. Now this is really stupid for checking for key is not equal to comma. Ideally, you would want to just ignore commas. There's literally no reason why I have commas here. But yeah, so we have that, and then if we go back to preprocessed generic classes. So once we're kind of set up with our identifier list, we have our list of identifiers. We want to basically figure out where we're going to put this class. So if it's at a global scope, we create a global class. And we've gone over this function before, so I don't really have to go into it. And here's where we add the less than and greater than symbol, just to kind of denote that it is in fact a generic class. We have our flags, the AST, and here's what's different, right? So before, when we would add a global class, we would add it to the um, where is it at? To the classes list. I can't find it in here for some reason. Here it is. Okay, so we'd add it to this class list, but this time for generics, you don't want to do that. You want to add it to the generics list. The idea behind this is one form of saving memory. Now, I just want to mention something very important. It's not really a bug, it's more of a unintended consequence of my compiler. I don't have the ability yet to basically block out code that's not being used. Meaning that I have this entire standard library, right? I have tons of files, tons of code that I wrote that does just all sorts of things. Basically, everything that the compiler is going to see, it's just going to dump it into this list. Meaning that you're going to get a ridiculous amount of code that majority of it you're not using, so your executable code is going to be humongous. So that's a bit of an issue that I'm working through. But at least with generic classes, the way that they're going to work, we're only going to add the generic class to the class list and assign it an address and, create the fields in any methods that are tied to it once we actually create the generic class. Because otherwise we don't know the type of it, so it makes sense to not add it to the class list and assign it an address. So just keep that in mind, and of course we create our full name like we normally do. Otherwise, we have our child class, which basically just creates a child class. Pretty self-explanatory. We've already seen that code. And then you create your full name this way as well. So now we get to the point where we want to finish up the full name. So up here, we basically start out the creation of the full name. So the full name basically encompasses everything that is basically going to be representing that class. So, what is the module that it was defined in? What are any higher up classes that own that class, and so on and so forth. So we start out by having just the module and hashtag in the class name as a global top level full name value, or we have the child class, so we get the full name of the previous class that owns this, and then we say dot class name, and then we build the final portion of the class name. What that's going to do is that's going to build the list of t's. So when we create this, we're going to have a full name of std hashtag list of t, and that's going to be the entire full name of this generic class. So that's all we're going to do. We're just going to for loop our identifier list and just add the values. Of course, I check to see if I is +1 is less than the identifier size. If so, that means that we still have more identifiers to process, so we add a comma. After that, we set the full name. We add all of the keys, so we call the add keys function, which just adds a list of keys to this class. And we free up the identifier list. And then finally, all we do is just check to see if it's an interface. So we're going to have a Boolean up here where we pass whether or not this class is in fact an interface. Now this isn't really necessary. Technically, I could just check to see like I did up here if the AST that we're passing is an AST generic interface declaration, but I just have that just because. So if it's an interface, then we set the class type to interface or class generic. And what that does is that basically enables both bits for this class. And this is why I have bit shifting, because a class can simultaneously be an interface and a generic class. So what that's going to do is that's going to enable the bit at 1. So if we go back to our little calculator here, we can go here. So class interface bit of 1 be assigned here, and then generic bit of 2 will be assigned here. So the value of the type of the class will be 3, and we'll have both of these bits enabled, so when we inspect the classes, we can check what we need to check. Actually, that's incorrect. So the bit address is 1 and 2, so it would actually look more like this. Because when we check for a normal class, that's the first bit. So it starts at index of 0, so when we do our right shift to check the type, we right shift 0 bits, meaning, and then we inspect this one. So there's that. After that, we have our class type of just generic. So if it's not an interface, it's just a generic class. Now, if you notice, I did not put class normal here because it's a generic class. So just keep that in mind, and that's it. The purpose of this, like I said before, is just to create the existence of the generic class. So once we actually come around to processing this in that compile generic class function that we saw up here, it will basically have like the basic information. So I have this function called transfer, which basically just copies all the code from the generic class. We'll see that later, but yeah. So that's it. This is pretty much everything. So now we're kind of gearing up to start processing our first class. It's starting to build up slowly, and basically once we can process our class, we're pretty much done because we've done enums, we've done generics now, and we've also done aliases and vars, with the exception of mutations, which are pretty simple to do. We'll do that one last because it encompasses basically everything that we've done here. So hope you guys enjoyed the video. As usual, if you guys have any questions, definitely put them in the comments section below. And of course, if you guys would love to help support the channel, definitely head over to my GitHub repository at androidevcd/sharp. And when you do, definitely watch, start, and fork this repository. That's going to give this repository a lot more visibility and let other developers know this language exists. Also, if you guys are curious about learning what I've been up to on a daily basis, you can head over to the remastered branch. And in there, I write some pretty wordy commits so you can kind of get a gist of what I've been up to without really having to look into the code. Now, I've been putting a lot of frequent commits lately with just one-liners, but typically I do write some pretty wordy commits, so you kind of get a gist of it, like I said. Also, if you guys are wondering about what are some of the things that I'm looking to add in the future, you can head over to the docs folder. And there's two main files. You can check out the changeless file, which is everything that I've done in the past, and the roadmap file, which is pretty much everything that I'm looking to add in the future. As a final note, before I go, we're getting pretty close. Once we basically finish the pre-processing stage, once we're done with pre-processing classes, what else do we have to do? So let me go up here and do a search. So after we pre-process our class declaration, and this is inside of, oh, that just recursively calls that same function. So once we do all of that, oh, and by the way, you do want to add this code here. So I know we've been kind of focusing on pre-process class declaration and some of the code in there, but I kind of bounce around, but you basically want to add this AST generic interface code to the high-level pre-process class. And once we get into pre-process class declaration, you'll also want to add all of the stuff that we learned previously, like processing aliases, generic classes, generic interfaces, enums, fields, and everything else. You want to add that into there, but we'll see that in the next episode. But like I said, before I go, we're pretty much almost there. So if I go back to pre-process, once we're done with this, all we have to do is just handle imports, which is going to be really quick, and then resolve base classes, and that's it. Once we're done with pre-processing, we're going to have to start building the virtual machine. Now, I've been scrambling for you guys as fast as humanly possible to get it done, so that way we can actually do it. But yeah, we basically are starting to get to a point to where, and I know it seems really early because we haven't really gone into too much in the compiler, but we're going to have to start building the virtual machine, at least the bare bones of it, so that we can understand what we're actually compiling. And this is in fact the exact order that I go in when I'm actually building a programming language, because once you pre-process everything, you're pretty much at a stopping point to where you can safely start doing that other part. Also, if you guys are curious, some of you guys, I know I've talked about my JIT before, and I haven't started working on it yet. I'm still fixing tons of other bugs in the language. However, if some of you guys are curious, it is a bit early, but if some of you guys are looking to kind of get ahead of the game and to get a jump on things, I use an API called ASMJIT. So if I go to, it's actually in my lib directory, and where is it? In my util, and JIT ASMJIT. So this API is actually what I use to basically program the JIT. It's in a very advanced and very amazing API. It basically allows you to write a JIT directly into the code. So you can literally just create like a function here, and I know this is like super low level, but like I said, we're going to have to actually start interfacing with this code, and it is a ton of stuff. So I definitely recommend checking out their GitHub page. So if I go here to the official repository, you can get there by going to github.com/asmgit. Now, my API that I have in my project is actually pretty outdated. Mine, it dates back to about a year, I think, and there's obviously been tons of updates. I mean, um, they update this code pretty regularly, but the code has a really nice documentation profile or index. So if I click documentation index, it has all of the things that you need to kind of get started with it. It has things such as build instructions, and of course, I'll go through the basics of how to set up ASMJIT and to use some of the tools that we're going to be using, because we're not going to use the full power of this API. We're only going to be using a subsection of it. But yeah, so if you guys are curious, like I said, definitely head over to ASMJIT, and you can pull down the master branch and just take a look at it. It's a really interesting API. But yeah, so that's what we'll be using. So hope you guys enjoyed the video. As usual, if you guys are new to the channel, definitely consider subscribing, and until next time, I'll see you guys later.